Now in some ways, this one's going to be a little easier. Going to do your last example. Big part of these is that you have to factor them. You need to factor this all the way. How do we factor the numerator? What do we do first? Common factors, remember? They're always first. Do we have a common factor?
Yeah.
Take it out. And what's left?
X squared minus 4.
There we go. That can be factored further because it's a difference of squares. The bottom can also be factored. Denominator. What is it? We need to get a product of 6 and a difference of 1, and the bigger one's negative. X minus 3, x plus 2. Got that? So we're going to factor a little further. This is 2 times x plus 2 times x minus 2, difference of squares, over x plus 2 times x minus 3. This x plus 2 divided by x plus 2 will almost always give me 1. If you take x plus 2 and divide it by x plus 2, if x is 1, you get 1. If x is 2, you get 1. You get 1 even if x is a million. 1,000,002 divided by 1,000,002 is still 1. You follow that? I can divide these out and eliminate them as long as x is never negative 2, right? So all I have to do is cross these out and write a little disclaimer on the side. X cannot be equal to negative 2. Graphically, it gives me a hole in my graph. The approaches are no problem. It doesn't matter how close I get to negative 2, I still get the same number over the same number, don't I? Even if it's a little tiny decimal, it doesn't have any effect on my graph. All it does is makes a little hole in my graph, and I have to do that at the very end. So basically, I get to ignore this completely and graph this equation. 2 times x minus 2 over x minus 3. I'm going to graph this equation, and I'm just going to stick a hole in it at negative 2. So, here's my equation. Give myself some space here. Okay. Where is your problem for x? Other than negative 2. 3 is our problem child. That gives us our vertical asymptote. At x equal to 3, or rather x not equal to 3, we get a vertical asymptote. All right, for the tricky part. What about when x is enormous? really big, doesn't this just cancel out? If x is really big, isn't this the same as this, more or less?
Yeah.
Take 1,000,000. You get 999,998, 999,997, and when you divide them, you get 1. Y equals 2. Looks familiar, doesn't it? Find your x and y intercepts and graph them. Here's a hint, guys. Take a look. The x-intercept is going to be on the x-axis. The x-axis is where y is always 0. Your x-intercept always looks like this. You have an x value and a 0 for y. Got it? Your y-intercept always looks like 0 something. In this one, I want to get 0 for y. So what do I need to put for x to get 0 for y? 2. Won't 2, 0 give me 0 in the numerator? It's right there. Now look at my y-intercept. What happens when I put 0 for x? What's this? Negative 4 over negative 3. That is positive 4/3, isn't it? Now watch those negatives. Graph positive 4/3. 0 4/3. It's right there. Can you all visualize what's going to happen here? We're going to get a curve here. Chances are we're going to get a curve up here. But what you've got to be careful of is that later on you're going to get ones that have curves that go like this. So you need to do the approaches to make sure you know where your curves are going. Got it? We're only going to do one approach. We already can suspect that this one is going to do this, yes?
Yeah.
Based on our intercepts. But we need to know whether this one goes here or here, and it could be either one. So what I'm going to do is I'm going to do my approach from this direction. I'm going to let x approach 3 from the bigger side. That means that I'm going to pick numbers that are just a little tiny bit bigger than 3. By the way, this idea of picking numbers that are really close to other ones and getting closer and closer and closer is all of calculus. The idea of calculus uses this, taking numbers and getting closer and closer and closer to things. It's called limits. And we use limits to do all of calculus. Now look, we're going to get closer and closer and closer to 3. What's a value for this? 3.1, 3.001, and 3.0001, and so on. Got it? So, I'm going to put this number into here. We don't care how many zeros are there. It's basically 3, isn't it?
Yeah.
Is this positive or negative?
Positive. Oh, it would be positive.
It's positive, yes? Because it's 3 point something? Y'all follow what I'm saying? All I care about is whether it's positive or negative. Positive. Now in the denominator, I get a really tiny number because I'm getting really close to 3. Positive or negative? Positive. Positive divided by a positive makes it go up, doesn't it? I realize that the first few times you do this, it's going to look horrible, but you have to get this down. It'll take a little while to get your approaches down. You have two homework questions. They're on the board up here. You might want to write them down somewhere because you're going to take a little quiz from last time we did more trig graphing, and I got a little quiz for you. This is number 1. It's y equals 3 over 2x minus 6. And number 2, y equals 2x squared plus 2x. Okay. Make sure you take some graph paper with you. Try and do a really good job on this and practice approaching those. Your quiz is going to be right back here on the table. If you'll turn in the protractors, you get to use a calculator on this test, on this little quiz here. So you can pick up a calculator if you want to. Y'all have almost exactly 30 minutes before they blast us with the announcements.